Hello everybody, welcome to Code Learning Central, where I'm going to teach you how to code in C the right way. Now, what do you mean the right way? I mean we're going to introduce you to a concept of top-down design, where we go ahead and we lay out what we're going to do before we start coding. This is a practice that is used by professionals everywhere. And I'm going to give you a real-world scenario to work with. So let's go ahead and look at what our problem is. We need to calculate a monthly car payment given the price, the annual interest rate, and the span of payment periods. This is an introduction to what top-down design is. You have your problem, and then you have it branch off into sub-problems. So let's go ahead and look at our sub-problems. Starting with our first sub-problem. We need to prompt the user for the price, the down payment, the interest rate, and the span of payments. We need to ask the user, hey, what are the key information that we need to plug into our formulas? So let's go ahead and start. Now, first thing we want to do every single time is we want to include our libraries that we're going to need in order to do our calculations. So to start off with the very simple, most commonly used library would be your standard inputs and outputs. This is what we're going to use to be able to prompt the user in order to get the information out of them. Now, we're going to include our standard library. Now, the standard library has pretty much all of the basic necessity commands that we need in order to get a lot of our function going. It includes the basic operators like addition, subtraction, multiplication, and division, and a lot of the definers for our variables. And then lastly, we're going to include the math library. This is how we're going to get some of our advanced mathematics in there so we can break down and simplify a lot of the things that, yes, we could do with the standard library, but there are some functions in there that make the process a lot easier. Now, second thing we're going to do is we're going to go back and look at our other subproblems to get a good idea of what we need to do. So we need to calculate the monthly payment. And we need to display the monthly payment to the user. Now, in order to calculate the monthly payment, we're going to have to put in a function. You don't have to put in a function, but this makes it a lot easier for us. So we're going to be introducing you to functions today. But first of all, let's go ahead and look back at prompt the user. And we're going to go in and just ask the user for some information. So, first thing we're going to do is get our main function out of the way, because every C program needs a main function in order to run. This is what your code runs in every single time. And we're going to tell it to return a numeral of 0. Now, why are we doing that? Well, as you can see, we predefined the main function as an int variable, meaning that is going to be an integer with no decimal places after the first integral number. So, when we're saying return 0, we want, after the code finishes executing, return the number 0 in order to tell us, hey, the program ran correctly. This is an introduction to Boolean logic. 0 means true and 1 means false. So if the program does not compile and run correctly, it will return the number 1 to us, saying, hey, there's a problem with your program and we cannot compile it. Now, let's go in here and just start going, asking the user for information. So we'll say printf, and we'll say, welcome to the monthly car payment calculator. Do an exclamation point and be happy. Make sure you put your semicolon after your executable statement. Then we'll say, what is the price of the car? Say, what is the price of the vehicle? And then we'll go ahead and put an arrow here, so it makes it a lot easier for the user to read. And we'll go ahead and put a new line. Now, this /n, this is basically saying, hey, we want to take the text from here, and then after this is done reading, we want to jump to a new line in our command prompt. So it just makes it a lot easier for the user to be able to read. Make sure you put your semicolon. And then we're going to do a scanf. And we're saying we want the user to put in some input. If you ever coded in Python before, this is pretty much the same thing as an input function. So we're saying we want the user to interact with the program by putting in data. So let's say scanf %, LF, and then we want to use a pointer and point that back to the price. Now, we have not defined this yet. So what we're going to do is we're going to go up here and we're going to define our first variable, which is a double, because we're going to have some sort of decimal after the integral value, because as you all know, with dollars there's cents, and then that cents goes after the decimal point. Pretty self-explanatory. So we'll say price as our first variable. Now, we need to ask the user for the down payment, because we want to be able to say, well, if you're putting money down on the car, then that's going to take away from the additional price. And if we go back to our subproblems, we need to ask for the down payment, because this will take away some money from the original payment that is needed for the car. So we'll say printf, new line, how much money are you putting down on the car? Now we'll go ahead and do another scanf and get the user's input and then point that back to the down payment. And we'll go ahead and add that as a variable. Now, what else do we need? Well, we need to know the interest rate. So we'll say printf, new line, what is the annual interest rate for the loan? And now we'll go ahead. And you know, this is a repetitive process, but this is definitely necessary. So scan LF again, and then we'll point that to the interest. And then we'll go ahead and add that as a variable. Now this is something that you could have done before, is add the variables on before you start doing this, but in order to give you a better concept of how we're defining our variables, where we're getting this from, I'm adding them after I go ahead and prompt the user for them. So now, the very last thing we need is to ask the user, how many months are you going to be paying this car? So, printf, new line, what is the span of months that you will be making payments? And we'll go ahead again, do a scanf, and point that back to our months. And we'll go ahead and add that. Now that we've already got this subproblem out of the way, let's go ahead and cross it off our list. So we'll say we are done with this. No more need for that. So now what we need to do is calculate the monthly payment. Now, this is a subproblem, and sometimes subproblems have multiple subproblems within them. So if we scroll down here, we have 3 subproblems. So let's go ahead and just look at the first subproblem, is calculate the monthly payment. So how are we going to do this? Well, the easiest way to do this is to write a function. So what am I going to do? I'm going to go ahead and create my first function prototype. How this works is we're going to tell the compiler, hey, I have a function I want to write, but I need you to know that I'm going to be putting in a function before we compile the main function. So I'm going to go ahead and do a prototype of calculate payment. I'm using Camelback notation for this. Maybe some developers would say that this is not the correct way to write a C program. But honestly, it is all up to who are you working with and what do they do. Because the most important thing about development is your code readable to other people? And if other people use Camelback notation, then I highly advise that you also use it as well. So we've got our type. What our function type is a double, meaning it's going to be a precise decimal with 64 bits of memory used. And we're saying that we want it to be called calculate payment. And now we have arguments. So if we didn't have arguments and we did not want to return a value, this would just be called void. As you can see in the main function, this also has void in it, meaning that we are not going to be using any arguments. So we're not going to have anything going in there. So if you put in void, you'll tell your compiler, hey, I'm not going to be putting anything into this function. But in this case, we will be putting something into this function. So what do we need? So let's go back to our subproblems and read what we need. So in order to do the calculation, we're going to take I times p divided by 1 minus 1 plus I to the nth power, negative n power. So to put this in perspective for you, I is the interest rate, p is the price of the vehicle, and then n would be the number of payments. So in order to do this, we need 3 arguments to plug into our function. So let's go back to our code and put in these arguments. So we need the price. So we need to first declare what kind of type that our variable is going to be, and it's going to be a double. So double P for price, double I for the interest, and double N for the number of months. Now, after we've done that, we put in our prototype. Now we need to write our functions. So let's go ahead, go to the bottom here, put in double, because we need to define what type of function that we're going to be returning. The value is what we are returning, and we need to clarify to the compiler what we are returning. It would be a double. So now we need to again write what we have. The easiest method of doing this is just copying what you already wrote instead of writing it again. Paste that in there. And now we need to put in curly brackets because this is now a function. As you can see, the main function has curly brackets containing all the data inside of it. This is saying this is what the function presents, and this is what's going to be running within that function. So let's go ahead and begin. Now let's look back at our top-down and see what we need to do. So first of all, we need to convert the annual interest rate into monthly interest rate. So now, we'll go back in here. And we need to remember that what we prompt the user is a percentage out of 100% of what the total interest rate will be. So we need to convert that percentage into a real number. So we'll say I equals I times 100, because whatever your percentage is, you take that times 100, that is going to be the real number. Now we need to divide that by the total price to get the added cost that is the interest rate. So we are going to divide that by the price. To reiterate that, we took I, which is the percentage of the interest rate, and we converted the percentage to a real number. In order to take that percentage of the actual price and get what is the additional value, if you include that percentage, you take the percentage and you divide it by the price of whatever you're buying. So now after we did that, we need to also take into consideration, looking back at our top-down design, that we need to convert that annual interest rate, the annual interest rate, into a monthly interest rate. So there's 12 months in a year. So if we take our interest and divide it by 12, we will get 1 month's worth of the interest rate. So we'll go back to our program, and we'll say I equals I divided by 12. We're saying we want to take the original value of I, and we want to divide that by 12, and then add that to what the variable I is equal to. We're assigning I divided by 12 to I. So, next step, we need to refer back to our formula because we got these two out of the way. So now we'll go back and we'll say we got these two out of the way. We converted it, and we calculate how much additional cost is added by taking that percentage and dividing it by the total price. So now we need to refer to this formula right here. This formula is what we're going to need to be referring to in order to get this calculation done. So I like to break this down into segments so we make it a lot easier for us in order to get what we need out of it and make it more readable to you so you have a better understanding of what we're doing. So let's go back to our code, and we'll say I equals I plus 1. Now you're thinking, well, how did I get this? So let's go back to our top-down design, and we're saying we want to get this right here. We want to get this out of the way. So that's what I'm getting from that. Then we're going to go down, and we want to introduce our exponent part of this. So what we're going to do here is we're going to add a variable inside of our function. And it's important to know that whatever variables you add within a function can only be used inside that function. This is what you call a local variable, meaning that if I try to plug in this variable power into the main function, the compiler is not going to understand and is going to tell me that I'm trying to use a local variable inside of the main function. So just keep that in mind when you're writing your functions. So now we're going to say power equals pow I to the negative n power. And put this into perspective for you. This is no different than saying we want I to the negative n power. This is what we are telling the C program when we say pow. Pow is how you do exponents, and this is coming from the math library. So we say we want I to be our base, and we want negative n to be our exponent. So after completing that, we will now have one part of our formula finished. We will be able to say we have this part of our formula done because this is what we just coded. So now we have to move on to the next part. So, if you remember, we added 1 to I. Now if we say we want to add this on to the rest of the formula, we're going to get an incorrect answer because we do not want I to have an additional 1 to it because this is not what is required by the rest of the formula. So we're going to go ahead and take I and subtract 1 by it. So it takes it back to its original value that it had after doing these two calculations right here. So we're saying I minus 1, and then we're assigning that to the value of I. Now, in order to get to our next part of it, we're going to say power equals 1.0 minus power. Now, where did I get this from? Well, if we go back here, we already got this right here. We said this equals power because we assigned that to that variable, this calculation. So now we're saying we want to get the denominator of this by taking 1 minus power. So we'll go ahead here to make this easy for you. We'll say this equals power. This guy right here. That equals power. So we're saying we want 1 minus power. So in order to get that, this is what we did. We said we want 1 minus power, and we want to assign that to the power variable. So after doing that, we want to go ahead and do the rest of our calculation because we just got the hardest part out of the way. So now we'll go ahead and assign another variable, and we'll call this payment, and this will be our final calculation. So we want payment to equal the interest times the payment, and we want that to be divided by power. This is our full calculation right here. Say I times P divided by power, which power equals 1 minus I to the nth power. Now, remember that we did I plus 1 to factor in the fact that we needed 1 plus I in order to get that I assigned in the power function. So now after we did that, we can go ahead and return the value that is given to us by that calculation. So we'll say return payment. And what we're doing here is we want to say, hey, after I do whatever it is in the function, I want to assign the value that I get to calculate payment. I'm returning whatever value I get to the top of the name of this. So later on, we'll be assigning a variable to this function, and it will take on whatever value payment is equal to. So we got that out of our way. Let's go back to our top-down design, and we're going to go ahead and cross this off our list. We got this out of the way. Now we need to go back up here and say, hey, we calculated the monthly payment. We got it done. Now we need to display the monthly payment to the user. So let's go back to our code, and we'll come in here and we'll say we need to get the payment we'll go ahead and make this easier. We'll need to get the monthly payment. So our monthly payment is equal to calculate payment, and we need to pass in the following arguments. We need the price, we need the interest, and we need the months. Now, remember what I said before. In order to get the true price, we need to factor in the down payment. So what we're going to do is take the price. We're going to say price is equal to price minus down payment. We're saying we want the variable price to be assigned the value of itself minus the down payment. So now this will factor in what the down payment was into the total overall price of the vehicle. So after doing that, we want to go ahead and make it easier for us to display our months, because your months aren't going to be a decimal point. And if we go back, remember, that we made months a double, which means when we display months, it's going to come out to a decimal point. Now it's going to be a decimal point of 0, but that is unnecessary because there would never be a decimal point within our months. So we're going to go back and we're just going to add another variable. Now there are a few ways you might be able to do this, but for the sake of making this easier on you, the viewer, we're going to go ahead and just add a new variable. So we're going to say int display months. Now what we're going to do is we're going to say display months equals months. Now what we just did there is we said we want to take this double value of months and we want to convert that to an integer because display months is an int type variable. So what it's going to do is it's going to take the real number value, the integral value of whatever the months variable is, and it's just going to cut off any decimal, making it into an int value type. So now that we got that out of the way, it's finally time to do our final step, display the monthly payment to the user. So we're going to use another printf function here. Or we're going to say printf, new line, calculations completed with a loan of %, 0.2 LF. Now what is this 0.2? I'm saying that I want to display the variable with only 2 decimal places because, well, how it works with currency, it only goes to 2 decimal places when you're giving your cent value. And we want to make sure to put a $sign in front of that to make sure that is known to the user that this is a monetary value. So, with a loan of 0.2 LF, and we'll go ahead, make this easier on you, the viewer. Where are we getting the LF from? Well, we're getting that from the price. So, after we got that in there, with a loan of how many dollars that the user puts in, and an annual interest rate of %, 0.1 LF %, and make sure that we add in there, this is the interest, and we'll go ahead and put a new line in here. I'll say, and a payment period of %D, because D would be displaying an integer value, an int. Go ahead and display months. The monthly payment would be $, %, 0.2 LF per month. So now we're saying we want to add that at the end of our monthly payment. Make sure to put in a semicolon afterwards. Now our program is completed, and we can go ahead and just review it again real fast. Go ahead and clean it up real quick. We got a lot of spacing in here that's unnecessary. Just make sure everything is looking proper. Make sure all your semicolons are in there, which they should be. We're going to go ahead and run this. So, make sure to save your program. Go into your command prompt. And we're going to say GCC -O. What we're doing here is we're telling the GNU C compiler we want to make a new executable out of a C program we just wrote. So youtubecarpay.exe, youtubecarpay.c. So now it's telling us, hey, we compiled it, it's all good. So now I need to go in here and say YouTube CarPay to execute the program in our Windows command prompt. So now it's asking us the price of the vehicle. We'll go ahead and say the vehicle is $35,000. And add a cent value, we'll say it's 34 cents. How much money am I putting down on the car? Well, average, I'll put down 5,000. What is the annual interest rate for this loan? Well, we'll say, I don't know. I got a pretty good credit score, so we'll say the annual interest rate is 7.8%. And how many months? I'll do a 5-year, so I'll say 60 months. Something happened. What happened? Well, as it is law, there's always going to be something wrong with your program. So now we have to look at what did we do wrong. So we found our issue. What I did here incorrectly is when I was scanning, I did not do a correct pointer. As you can see here, I forgot the ampersand for this. So we'll go ahead and save this again. Go back to our command prompt, and we will do it again. So the price of our vehicle is $35,000. I'm putting down $5,000 on the car, and I want my annual interest rate to be 7.8%. And I want to pay for a period of 60 months. So, as we can see here, our total price of the loan will be $30,000 with an annual interest rate of 7.8, and our monthly payment will be $533.74. Let me know in the comments if you learned anything today, if you have more questions, or if you want me to go into deeper depth of the C programming language. I appreciate you watching, and I hope you have a great day. Thank you.